Alright, so good day, great day. In this video, we are going to talk about a new discussion with regards to our polynomial. Alright, so before that, as usual, let's have our short opening prayer. In the name of the Father, the Son, and the Holy Spirit. Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joachim, and Saint Anne, and Guardian Angel, intercede for me so that I may be deserved to be helped and saved today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, and the Holy Spirit. Amen. Alright, so in this video, we are going to talk about a new discussion, which is polynomial of, or the division of polynomial, and as well as the synthetic division of polynomial. No? Alright, so in this topic, we are going to learn how to use the long division and how to divide polynomials by other polynomials, and how to use synthetic division to divide polynomials by binomials of the form x minus k. Alright, and as well, we are going to uh, know how to use remainder theorem as well as the factor theorem. Alright, so let's start with an example of two polynomials that are being divided to each other. Alright, so the first example is x cubed plus x squared plus 4x minus 6. Okay, divided by x minus 1. Alright, so in a division form or in a horizontal form, if we're going to write that one, it will be x cubed plus x squared, alright, plus 4x, alright, minus 6 is divided by x minus 1. Alright, so that is how in horizontal manner. Alright, but we're going to try how to divide this one in a long division form. Alright, so process of dividing two polynomials, is that we're going to find, or we are going to arrange it in a long division with a a division bar, alright. And we are going to divide as well. We are going to divide this polynomial inside the division bar in a normal way, no? So we usually do is to find the first digit of the number, isn't it? So in this time in polynomial, we are going to deal with the first term. All right. So how are we going to deal with this in your first term, no? In the first term of your dividend. So from your divisor, which is x minus 1, isn't it? You're going to divide the variable. All right. So the variable of the divisor towards to the first term of your dividend. So how are you going to divide a variable to the two variable? Anyone? All right. So as you will remember, okay, as you will remember, how do we multiply? How do we multiply variables? Then, if we are going to multiply a variable, we have the operations of, or the basic fundamentals, which are addition, subtraction, multiplication, and division, isn't it? So in polynomials, we have the word coefficients and variables, isn't it? So coefficient stands for numbers, all right, and they have this variable beside with it, isn't it? So if you have a variable of any letter, for example, let's just say x, and your coefficient would be 3. So this is 3x expression, all right. Our coefficient is 3 and our variable is x. Now, if you are going to add the expression like 3x plus 2x, we're going to get what? We're going to get 5x, isn't it? Alright. So, what happens? Okay. What happens to our variable? Okay. So, if they have the same, uh, if they have the same power, the degree, we could just simply add them. Alright? But, here's the thing. Here's the catch, ha. If you're going to add them, for example, with different degree, for example, 2x squared plus 3x. So, our expression will just remain as it is. Okay? Alright. So, if we are going to multiply two expressions just like 3x multiplied by 2x, what do you think will be the answer? The answer would be 6x squared. Oh, so what did you notice? Your coefficient was multiplied to the other coefficient, isn't it? Alright, so that is correct po, no? So your coefficient was multiplied to the other coefficient. But how about your variable? What happened to your variable? Your variable was added. So the degree of your variable was added. So it means when you are multiplying a variable, what happens to the degree? The degree is adding up. Okay, they have the operation to add the powers. Okay, all right. So that's how we deal with it. Now, if you have what we called as checking, for example, in a basic uh, given, just like 5 plus 2, isn't it that you are going to have 7? So what you used is addition. If you're going to check, you're going to check if 7 is really correct. You're going to subtract the sum to any number. No? So let's just say 2. So 7 minus 2 is equal to 5. So we could say that the given that you have, the two givens that you have, they have the sum of 7. So it shows here that your answer was correct. So what you have at the first place, no, from your given was addition. Then by checking, what are you using? You are using subtraction. So same goes by with the multiplication, isn't it? In the basic equations, no? For example, you use addition, then in checking, you are going to use the other operation, no? Or the opposite operation of that basic fundamental operation. For example, you use addition at the first place. If you are going to check, you are going to use subtraction. So same goes by, if you're going to use multiplication, by checking, you are going to use division. Correct? Gets already? Alright. So with that said, let's try to go back from where did we stop? Alright. So we multiplied this expression. Okay, the 3x multiplied by 2x. So once again, once you multiply, what happens to the variable? You add. Okay? So therefore, if you are going to divide, what happens to the variable? It will be subtracted. So if you have 6x squared, okay, divided by, let's use 2x. 2x, okay, what happens in here? So you're going to have, what? You're going to have 3x. Why? If you're going to divide 2 to your 6, what will happen? It will become 3, no? And if you're going to divide x squared to your x, what happens to the variable? The power of the variable subtracts, no? So they have the operation of subtraction. So the x squared will be subtracted of one power or one degree, so it will become 3x only. So then right after that one, you just do what we usually do in division. All right, so gets already. That is what happening. No? That's what's happening in division or dividing a polynomial. Okay, so going back, ha. So if you're going to divide this one, we're just going to deal with our expression because this is our constant. Okay, so may I tell you, ha, we are going to have this confusion. Expressions, correct? Polynomials. So this is our expressions and this is our constant, ha. The last term that doesn't have any uh, any variable, that is what we called constant. Okay? Coefficient are different from constant. Take note of that one, ha? Because coefficients are besides with the constant. Okay? Alright, so sige po. Going back, so we are going to divide the first term of this polynomial by with the expression which is x. So if you're going to divide x cubed divided by x, the answer will be x squared. So in the first place, we are going to divide the x to our x cubed. So what will happen? The answer is x squared. Okay, so we are not going to put the answer above of that first term. That's the difference when you are going to divide polynomials. Because in the usual way, we're going to place the answer where did we get. No? Where did we get our answer? So in this case, we're going to put our answer to the term next to it. Okay? Alright, so it will become x squared multiplied by x. Okay, the answer will be, okay, x squared multiplied by x, the answer is x cubed. X squared multiplied by negative 1, the answer is negative x squared. Correct. So that will become like that. So in usual way, after we multiply the quotient to our divisor, no? So we got our new dividend, isn't it? So we are going to subtract them. Correct. But in this case, because they are in polynomials, what happens to our operation subtraction will be distributed to each term. So your operation of subtraction will be distributed to each term. So your negative x cubed, your positive x cubed will become negative x cubed, no? Will become negative x cubed. Your negative x squared will become positive x squared. Okay? Then what happens to the operation? It will become addition. So you are going to add x cubed with negative x cubed, no? So that is how that is what happened that is what's happening in polynomials, no? But in my case, personally, no, this is what I'm doing. So uh I'm just putting a bracket, no? Bracket, then I just subtract. So x cubed minus x cubed, the answer is 0. So uh, positive x squared minus negative x squared. So the answer is there. Okay, so but in the proper way, because there are steps to be followed. As I said, the usually is we are going to subtract. So we are going to subtract, but we are going to change sign as well as the operation of subtraction. It will become addition. Okay, so we are going to change the uh, signs. Okay, then we add. So same goes by if we have the parentheses, isn't it? So if we're going to add them, the answer would be 0 and 2x squared. Okay, take note, 2x squared. Alright, so after that one, what will happen next? We're going to bring down 4x. As usual, next term, isn't it? Or next digit in the normal way of dividing. So we're going to bring down 4x. So right after that one, we are going to divide x minus 1 to the new dividend. This is our new dividend, isn't it? So once we bring down, we are going to divide the first term. What's our first term now? Our first term is 2x squared. No? So we're going to divide the x to our 2x squared. So 2x squared divided by x. The answer is how many? Of course, 2. How about the variables? If we're going to divide the variables, the answer will be correct. It will be subtracted. So the answer will be 2x only. No? So the power or the degree will be subtracted for whatever degree the divisor has. No? So 2x squared, we're going to multiply 2x squared to our expression. No? To our binomial. So you are going to multiply it to both terms. Okay? So it's like you're just distributing it. Okay? Alright. So if you're going to multiply 2x to your x, the answer will be 2x squared. And if you're going to multiply 2x squared to negative 1, what will be the answer? The answer will be negative 2x. Correct. So we're going to multiply it, and the answer will be this one. Correct? Alright. Then, what's the next step? We're going to change signs. Then, we are going to add them. Correct. Then, if we're going to add them, we will be having 0. Of course, 0. Because if you will add this 2, it will become 0. Then, if you're going to add 4x to your 2x, positive 2x, no? Obviously, the answer will be 6x, no? Then, what's next? What's our last term? The constant. What is our constant? It is negative 6. And if we're going to have negative 6, of course, you are going to bring down that negative 6. Correct? Alright, correct. Now, the terms that you have is 6x minus 6. Correct? Alright, so this is our new dividend. And you are going to divide x minus 1 to your 6x minus 6. And with that, what will be your quotient? 6x minus x, the answer will be, they have the same degree, isn't it? Your variable here has the power of, or the degree of 1, isn't it? The degree of 1. And your 6x, your x here, have the degree of 1. So if you're going to minus them, what will be the answer? Of course, it will become 0. Correct? But this is the question. If your variable, any variable, no? Any variable or any number, if you have the power of 0, what is the rule? Rules of exponent. Any number, any variable, once you have the power of 0, the answers will be always at 1. Any number, any coefficient, any number, any variables, when you have the power of 0, it is always equals to 1. Correct? Please remember that one, ha? So in this case, you're going to divide, no? 6x divided by x. So obviously you will be having 6. And from your x divided by x, it will become x is equal to 0. Correct? But the equivalent of x is equal x raised to 0 is equal to 1. So 1 times 6, obviously it is just 6. Okay? So please remember that one, ha. Alright. So right after that one, we will be having only 6. Okay? Positive, ha. Why is it positive? Because it's positive, oh. This is both positive. Okay? Please remember that one. Alright. So having that one, we are going to multiply it. Okay? We are going to multiply it on what is the normal way? How to divide. Okay? So if we're going to multiply it, just like in distribution, so 6 multiplied by x, the answer is 6x. And 6 multiplied by negative 1, of course, it will become negative 6. And you will be having 6x minus 6 as well. And with that, we are going to change the signs, then add. Okay? Then add. And of course, if you are going to add this all, what will be your answer? The answer will be 0. Okay? So what is our quotient? Our quotient will be x squared plus 2x plus 6. Please take note of that, ha? Sige po. Please wait. Alright. So, some of you, no, not really some of you, but all of you, has this secret, I guess. This given, and as well as this given. Correct? No. This is the first given, I guess. First given, this, then followed with this. Okay? Sige po. So, let's try to have this next example, no? For long division. So, next example is that x squared plus 8x plus 15 divided by x plus 3. So, as the usual way, how are we going to divide two polynomials? We're going to base to our expression. Okay, then we are going to divide the first term, which is x squared. And if we are going to divide x squared to your x, obviously, what happens to your power or to the degree of each expression or each variables? The degree are having the operations of subtraction, of course. So x squared, x squared divided by x. What happens? 2 minus 1, the answer is 1, of course. So in this case, we are going to have the answer of 1. And with that, what's the next step? We're going to multiply x to the two terms. Okay, so it seems like distributing only, no? So x squared is the answer. Plus 3x, because we're going to multiply x as well to your constant. Okay, so it will become 3x. Now, when you have x squared plus 3x, what will happen next? The next step is to change the sign, then you add. Now, if you're going to add x squared to negative x squared, what will be the answer? 0. Then, 8x plus negative 3x, what will be the answer? It will become 5x. Then you bring down 50. Correct? Okay po. Then, what will happen next? This is your new dividend. And that is what you are going to divide next. So, our first term in here will be your 5x. And you are going to divide 5x divided by x. And in that case, same goes by a while ago, ha? 5x divided by x. Isn't it that you have invisible 1? So, 5 divided by 1, the answer is 5. X divided by x. X divided by x. The answer will be 0 or 1. Correct? So therefore, 5 times 1, the answer will be 5. Of course. So, in that case, the final answer will be just simply as 5. And after right after that one, you're going to multiply 5 to the two terms or to your divisor. No? So 5 multiplied by x, the answer is 5x. Then 5 multiplied by 3, what will be the answer? It is positive 15. Correct. And with that said, you have 5x plus 15. Then what will happen next? You're going to subtract them or change the sign, then you add. Correct? Then, if you're going to change that one, what will be your answer? The answer will be 0. Alright, so what will be your answer right now? The answer is x plus 5. So let's try to check if your quotient is correct. Okay, so by checking, you have x plus 3 multiplied by x plus 5 by FOIL method, first term to first term, outer term to outer term, inner term to inner term, then last term to last term. No? So your first term will be x squared. Your outer term, which is your outer term. This is your outer term. I'm sorry, this one. So it is x multiplied by 5. So it will become 5x. No, 5x. Then your inner term, which is your inner term? 3 and x. Isn't it? So you're going to multiply 3 to your x. So it will become 3x. And lastly is your last term. Which is your last term? It is 3 and 5. So 3 multiplied by 5, the answer will be 15. No? So in that case, what expressions or what terms can you see in this polynomial which are common? We have the 5x and 3x. They have common terms, isn't it? They have both degree or both power. So you are going to add them. So we are able to add them both because they have the same power. So 5x plus 3x, what will be the answer? The answer will be 8x, correct. So the final answer would be x squared plus 8x plus 15. Okay, that is our final answer. And if you will notice, no, as your product from your checking, the product is just the same with your dividend, correct? So therefore, our quotient, no, from your long division is correct. Okay, all right. So next, this is the terms that we have for your sequence, isn't it? So let's go on with our synthetic division. Okay, so from our synthetic division, how are we going to? Synthetic division is just like your long division. No, all right. So the difference with them is that from your fractional bar, so in your long division you use this kind of fractional division bar. Okay, but in synthetic division, this is somewhat different from your usual long division. No, so what are you going to do in synthetic division is that from your polynomial, you're going to get your coefficients. No, that's the difference between the long division and your synthetic division. No, so let's have this as an example. So we are going to divide x raised to 4 minus 10x squared minus 2x plus 4. So you're going to divide this polynomial by x plus 3. Okay, so in long division, we are going to divide this in a way of this format. No, so x raised to 4 minus 10x squared minus 2x plus 4 divided by x plus 3, isn't it? So that is how we placed it, no, in a long division. But in synthetic division, we are just going to get the coefficients per term. So what is the coefficient of this first term? The coefficient will be 1. How about to your second term? What is your second term? It is negative 10. Please take note. What is the degree of your first term? The degree of your first term is raised to 4. So, of course, your second term will be, no? The second term should be x raised to 3, isn't it? But did you did you see any terms that has the power of 3 or the degree of 3? No. So we don't have any degree raised to 3, isn't it? So what are we going to do to the coefficient? So of course, possibly the coefficient of x raised to 3 or x cubed, the coefficient of that one will be 0 because if you're going to multiply 0 to your variable, of course the answer will be 0. So therefore, no, in this polynomial, it seems like you have x raised to 4 plus 0x cubed minus 10x squared minus 2x plus 4. So it seems like that. So what happens in your coefficient for your second term will be become 0. Ha! Then what is your third term? Your third term will be uh, negative 10x squared. Okay, that will become that is your third term. But if you are going to ask, so in your perspective, if you're going to look at it, your second term will be negative 10x squared, no? But in placing the coefficients for your synthetic division, okay, the second term will be 0x cubed. Okay, so our third term in your synthetic division will be negative 10. Okay, so what's the next term? Based from the degree, ha? So the next term will be negative 2x. So the coefficient in this place will become negative 2. Okay, then are we going to add this constant? Yes. No, because it's still a number, not variable. So we are going to place 4 in the last term. Okay? Correct. So I'll just erase this one, ha. So this is our coefficients. Okay? So what is our divisor? We're going to put x plus 3. Of course, we are not going to put x plus 3 as it is. We're just going to put good morning, Sir Jerby. So we're going to put the coefficient. Oh, what's the coefficient of x plus 3? 1x, isn't it? But I want to correct this one, ha, because if you're going to put 1 for your divisor, it will not be correct. No, the process of your synthetic division will not be correct. So what are we going to do in here is to get the zeros or the roots of your division. Take note. How are you going to get the roots of factors or a binomial? For example, you have a factor. How are you going to get the roots? If we say roots, that is zeros. So how are we going to get the zeros? Using by ZPP. What is ZPP? That is zero product property. So you are going to equate this binomial to 0. If you are going to say equate the factor or equate the binomial to 0, it is just that it is just like this term, ha. So you have x plus 3 is equal to 0, ha. If you're going to equate this factor or this binomial to 0, the format is this one, right? Okay, so if we're going to find the root, what are the term that we are going to find? The x. Okay, so we are going to find the value of x in that factor. So what will be what's the value of x in this manner? So the value of your x will become negative 3 because you are going to transpose the positive 3 from your factor going to the other side. No? So as I mentioned last in our first week in this second quarter is that we're going to subtract both sides, isn't it? Because whatever you do in your left side, you're going to do it in your right side. Then, as I mentioned a while ago, it will become negative 3. So therefore, your x will stand as negative 3. Okay, so we are not going to put the variable itself because what you get, what you placed inside the division bar is your coefficient. So therefore, you are going to place the roots of the divisor, not the expression itself or the variable itself, because you didn't even move or use the variables of the dividend, isn't it? So don't use the variable as well. So we'll be having the divisor of negative 3. But I will be asking you, how are you going to divide this one? Are you going to divide this one in normal way? Or the normal setup that we have in our long division? Of course, no. So here's how, no. So in the first place, if you have this first term, which is 1, second term is 0, third term is negative 10, fourth term is negative 2, and your last term is 4. So what are you going to do in the first place is to bring down your first term. What's your first term? It's 1. So you're going to bring down 1. So the answer is 1. Then what are we going to do next is to multiply this 1 to your divisor. Okay? So if you're going to multiply 1 to your negative 3, the answer will be negative 3, of course. And with that, you're going to add this to. That's the time that you are going to add, just like what we did in our long division. Now, so if you're going to add 0 to negative 3, what will be your answer? The answer will be negative 3, of course. So with that, you have negative 3 already. So we are going to multiply your negative 3 to the divisor, which is negative 3. So negative 3 multiplied by negative 3, what's the answer? The answer will be positive 9. Oh, teachers had the signs. Alright, so it is positive 9. So if you're going to add this product or the answer positive 9, you're going to add this positive 9 to the third coefficient, which is your negative 10. So if you're going to add negative 10 to positive 9, what is the answer? Negative 10 added by positive 9 or added by 9, the answer will be negative 1, of course. So, same process. What are we doing? Just like a while ago. So, negative 1 multiplied by negative 3, what's the answer? The answer will become positive 3. Okay? So, if you have positive 3 already, we are going to add them still. So, negative 2 added by 3, the answer will become positive 1. And in that case, we have positive 1 multiplied by negative 3. We are going to have the product of negative 3. Okay? So, in the last step, we have this last terms, isn't it? So, we're going to have 4 added by negative 3. So, of course, our answer in here will become positive 1. So, if we have these answers below, how are we going to convert this one into a polynomial? That's the question. How are we going to convert this coefficient terms, no, to a polynomial once again? Because what you have a while ago is the polynomials that has variables and degrees, isn't it? So you are going to place it in a manner of this term po. Okay? So you will notice, what is your highest degree? Your highest degree is raised to 4. So it is x raised to 4, isn't it? Okay, correct. So what happens in here is that the first term, no, or first coefficient term that you have below is that you're going to connect it, no, or place it with the followed term, no, or followed degree of your highest degree from the first part. No, so what's your highest degree? It is x raised to 4, isn't it? So what is the next term to it? Isn't it that I mentioned a while ago? It is positive 0 x cubed, isn't it? So your x cubed is the next term that you will be using from your to your quotient. Okay, so it is raised to x cubed. Then your 1 will become your new coefficient. So therefore, if your highest degree is 4, the next term that you will be having is raised to 3. Okay, followed by raised to 2, then followed by raised to 1. And your constant. Then, what happens is that you're going to depend from this coefficients that you have, which is 1 for your coefficient, negative 3 for your second term, negative 1 to your third term, okay, and positive 1 for your constant. Okay? Gets? But, what is this one? Because as we mentioned, this is for your x cube, this is for your x squared, no? And this is for your x raised to 1, or x, and this is for your constant. Then what is this one? This is what we called our remainder. All right. So, if you have the quotient of this polynomial, of of course, you have still the remainder. In dividing, isn't it that we have remainder even in a basic division? Of course, if this will become your remainder, how are we going to put that one as your remainder? Are we going to put just like simply as this one? No. So you're going to put that one as in a manner of this term, ha? So 1 divided by x plus 3. Okay, that's the manner, ha? Are you going to put your remainder? Okay? Please take note of that. Alright, so that's how we do synthetic division. Okay? Alright, so next. So let's have this factor theorem. So if we say factor theorem, this is the definition, ha? A polynomial of f of x has a factor of x minus k if and only if f of k is equal to 0. So it only stated that if you have, if your f of k is equal to 0, then the factor x minus k is a factor of f of k. Okay? If your f of k is 0, ha, if it equals to 0, therefore, we could tell that your divisor or x minus k is a factor of your f of x. Your f of x is the dividend, no, or the polynomial that you are dividing, no. Alright. So we are going to have this example. So let's show that x minus 2 and x plus 3 are factors of 2x raised to 4 plus x squared, 7x cubed minus 4x squared minus 27x minus 8. So we're going to show if this x minus 2 and x plus 3 are both factors of this f of x. So we're going to show how. So how are we going to show if these two factors are factor of f of x? So you are going to use synthetic division. Okay, because in synthetic division, we can easily determine if you have the remainder or not, isn't it? So well, in long division, you can still you're able to see if you have a remainder still, but in synthetic division, it's much easier to identify if you have remainder or not. So in dividing this polynomial using synthetic division, you're going to get the coefficient. What are the coefficient? It is 2, positive 7, negative 4, negative 27, and negative 18. Ha? So are there any expressions or are there any terms that are missing? Starting from your highest degree, which is your highest degree? It is x raised to 4. So 4 going to third, second, and your first. Okay? So it is complete. No? So you're going to put the coefficient of these terms as well as the constant, ha. So once you inputted it already, so what happens next is that you're going to get the first term, first factor that you have, because this is what we are trying to show. No, if these terms or this binomials are factors of this f of x. So in getting this binomials, we're going to get the roots of it. No? So if we're going to get the roots of it, we are going to equate this binomial to 0. What's the equation of this term or this binomial? We're going to have x is equal to 2, correct? X minus 2, we're going to equate that binomial to 0. It will become positive 2. Therefore, we're going to have the divisor of positive 2. Okay? Alright, so by synthetic division, we are going to bring down this first coefficient. Okay? So we are going to have 2. Then you are going to multiply this coefficient to your divisor. Okay? Alright po. So, once you multiply it, what is the product? The product is 4. Then, what's the next step? You're going to add. Add this coefficient to the product that you had. So, 7 plus 4, the answer is 11. Then, same goes by, you're going to multiply 11 to your positive 2, and you will be having 22. Same goes by a while ago. You are going to add negative 4 and 22. Then you will be having 18. Same goes by. We're going to multiply 18 to your positive 2. The answer will be 36. And we're going to add once again. No? If you are going to have 27 added by 36, the answer will be 9. And for the last term, we are going to have 9 multiplied by 2, the answer will be 18. Correct. So, negative 18 multiplied by positive 18. What is the answer? If you're going to add them both, the answer will be 0, of course. So, from the definition of this factor theorem, no, if your f of k is equal to 0, so we could tell that this binomial is a factor of your f of x. Let's try ha. Let's try po. Let's continue. This is the one that we had ha. Okay. So, coming from the coefficients that you have, you're going to get the next binomial, which is x plus 3. You're going to equate that one to your 0. The new divisor will be negative 3. Okay? Negative 3 ha. Alright. So, if we're going to divide that negative 3 to the coefficients that you have already, so same process that you have already. We're going to bring down the first coefficient, then you multiply it, then you have negative 6. Okay? 2 multiplied by negative 3, the answer is negative 6. Then you add them both. Okay? Once you add them already, you're going to have 5. And once you have 5, we're going to multiply it as well, what we did a while ago. Okay, so we have 5 multiplied by negative 3. The answer is negative 15, of course. Then, once you are going to add it already, you're going to have 18 plus negative 15. Integers ha. So, the answer is positive 3, correct. So, in this case, you have negative 3 multiplied by positive 3. What's the answer? It is negative 9. So, in adding these two coefficients, what is the final answer? The answer is still 0. They are the same 0 at both ends, isn't it? So, from the definition that we have in factor theorem, okay, if your f of k is equal to 0, so therefore your binomial or the divisor that you are getting, is a factor of your f of x. That is what factor theorem is. Okay? Alright. So, last, uses of remainder in synthetic division. Alright. So, by definition, the remainder are obtained in synthetic division of f of x by x minus k provides the following information. So, in this case, we have r is equal to f of k. Okay, then second is, if r is equal to 0, then x minus k is a factor of f of x. Please remember, if your remainder is 0, then we could tell that your x minus k, or the divisor that you are, the binomial that you are dividing to your polynomial, is a factor of your f of x. Okay, then lastly, if r is equal to 0, then the coordinates k and 0 is an x-intercept of the graph of f. Okay? So, if you're going to have what factor theorem is and remainder theorem is, that we could tell that if you have the remainder of 0, you could just simply input the conclusion of this factor, or x plus 3 and x minus 2 is a factor of, then you state the polynomial. Okay? But when it's not 0, when you have a number on it, and you have a remainder, just like for example 1, 2, we could just simply state that it is the remainder, or 1 is the remainder of, then you tell the polynomial. Okay? Alright, so that's how easy factor theorem and remainder theorem. Alright, so with that said, let's have the end of the session. So I do hope that you learned something with this recorded video. And I do hope that for those students who have questions and who have concerns with the other lessons, don't hesitate to ask. And uh, kindly tell what's your sentiments are as well. Okay? So with that said, thank you for watching. I hope that you like this video and see you in the next video. Thank you. Bye.